All right, guys. So today we're going to look at acids and bases, what they are, how you can test if something is an acid or a base, and then also look at some examples of some acids and bases. You'll be able to see here in a few minutes that you use a lot of these things on a daily basis. So you can at least start to identify whether it's acidic or if it's a basic substance. So an acid, what is an acid? So typically when you think of the term acid, you think of something like burning or it being something that's bad. So an acid the definition is it's an ionic compound that breaks apart in water that forms hydrogen positive ions, meaning it just breaks apart and would provide a hydrogen atom that's positive. So the main thing that you need to know is that acids will taste sour if you're tasting them. I do not recommend just putting any chemical in your mouth without knowing what it is. They'll react with metals. They can be harmful to your skin. The stronger the acid, the more it can burn your skin. And so some examples of that are, everyone has this in your stomach. Your stomach has an acid in it that helps break down your food, which allows it to digest. Apple juice is acidic, but it's not harmful to you. Orange juice is acidic. Lemons are acidic. Again, none of those things are harmful to you, so you can ingest them or eat them or drink them. Soft drinks are acidic. Battery acid, which is a pretty strong acid and could be very harmful if you touch it. And then tomatoes are another example of an acid. There's bases. So bases are, again, an ionic compound. So they're atoms that are combined together, and they break apart in water, and they form a hydroxide negative ion, which means it forms hydrogen and oxygen, but they're negative atoms. Again, the key thing that you'll want to know is that they are bitter tasting if you taste them. They can feel very slippery or soapy. And then as acids do, a strong base can burn your skin and be harmful to you. So some examples, laundry detergent, which you use when you wash your clothes, that's a base. Baking soda is a base. Ammonia, which a lot of people use for cleaning. Antacids, like if you have an upset stomach and you take a Tums or like Pepto-Bismol, those help coat your stomach and help to kind of like prevent the acid in your stomach from causing your stomach to be more upset. So an antacid like that is a base. And then bleach is actually a base as well. So how we test whether or not something is acidic or basic is by using the scale that's called the pH scale. And the scale is color-coded as well as numbered. So you can see over here in this picture, it shows you that the acids are going to be going from the middle here starts like 6 to 1. So that's going to be showing you acids. And then your bases go from the 8 to the 14. So the scale goes from 1 to 14 in total, and then based on what you're testing, you'll get a color, and that color then aligns with a number. So if you get a really, really deep dark red, then it's an acid. If you get a really, really deep dark purple, then it's a base. And then you can see the colors gradually change as you move down. I will be doing some demonstrations of this during your live session this week. So I'll be testing different chemicals and showing you how that works. You use this, it's pH paper. It's like a yellowish color paper, but you can see that the colors are down here at the bottom. It helps you identify what color the paper changes when you dip it into the substance. And then that tells you whether it's an acid or a base and where it falls on the scale. So an acid, like I said, on the pH scale is going to be from 1 to 6. The strongest acid is going to be a 1. And then the weakest acid is going to be a 6. So you can see down here, there's some examples. So battery acid and stomach acid are towards the end of the pH scale. So that's meaning it's very strong and it would be very harmful to you. And then it moves up to a lemon, to sodas, to tomatoes, to coffee, to milk. So all of those items moving up the scale to the green there are showing that they're still acidic, but they're a weak acid. So for a base on the pH scale, it starts with 8 and it goes to 14. So the weakest base is going to be your 8, 9, 10 area. So down here, some examples are like blood, egg whites, stomach tablets, meaning like those antacids like Tums. And then it goes up to 11, 12, 13, 14, 14 being your strongest base. So then it goes to some ammonia, soap, bleach, which is pretty harmful, and then drain cleaner. So all of those things as you move up are going to be a stronger base. There is one number on the pH scale that's considered a neutral. So that means it's not an acid or a base. And so a neutral is going to have a number of 7, and it's going to be that like limeish green color on the scale. And the example of a neutral is just pure water. So you don't want to test necessarily bottled water if it's been filtered in any way. You would want to just be testing pure water, and that would give you a 7 on the pH scale. So this is just an image of some of the paper that I was showing you that I'll show you during live sessions. This is just the paper after being dipped in different substances. So you can see that the color changes from that orangish yellow color to the colors that correspond with it at the bottom. So like this deep dark red is a 1, then it gets kind of like an orangish reddish color, and that's your 2 and 3s. It gets into a little bit of a yellowish green for your 5s. 6s is a little more green. 8 is going to be like a super dark green, and then it gets into the blues and the purples. So those are actual pictures of pH paper that's been dipped in different substances to test whether it's an acid or a base. So again, these numbers 1, 2, 3, 5, and 6 down here are going to be your acids, with 1 being the strongest acid. And then your 8 through 11 goes to 14, but this just shows these examples. But the 8 to 11 is going to be your base. And the higher the number for this, the stronger the base is. So again, here's just another image. These are actual pH papers dipped in different chemicals to show you. You can see sometimes it is hard to tell the difference between them. And so that's why it's important that you have the color coding system that you can hold it up to see what it actually falls under. So again, the higher the number on the base, the stronger the base is. The lower the number on an acid, the stronger the acid. So that 1, 2, 3 is going to be your stronger acid. Then that 4, 5, 6 is going to be your weaker acid. Your 7, 8, 9 is going to be your weaker, your 8, 9, 10 is going to be your weaker base. And then your 11, 12, 13, 14 is going to be your stronger base. That 7 being a neutral. So 7 is not a base or an acid, it's neutral. That's what it's called. So you will get some practice with this. We're going to do a gizmo tomorrow. And I'm going to have a video linked here that you're going to watch, and it'll show you again, it's someone actually doing live tests of different substances, and then I'll be doing some examples as well in live sessions.
Hello, my name is James Lincoln. I'm a science teacher, and today I'm going to tell you how to do experiments with the pH scale. Now, before you start using pH paper, you can actually get a general understanding of what something's pH is by using just red and blue litmus paper. For example, if I test the lemon juice with this blue litmus paper, you can see that it turns pink or red. And that lets you know that the pH is low. It's an acid. It has a pH lower than 7. We don't know exactly what the pH is, but we know that it's lower than 7. If I test this baking soda with the red litmus paper, it turns it blue. That means that the baking soda is a base, and it has a pH greater than 7. We don't know what the pH is, but it is greater than 7. Now, what about salty water? I'm going to test it with the blue litmus paper. and it doesn't have any effect. The salty water just leaves it blue. So I'll now test it with the red litmus paper. Salty water, also no effect. It appears that the salty water has a pH of 7. It is neither an acid nor a base. The same thing happens with regular water. One more important test is, what if you test a base with blue litmus paper? It doesn't do anything because bases don't change blue litmus paper. The base is going to be either 7 or above. One of the best ways to know whether something is a strong or weak acid or base is with pH paper. pH paper tests the pH and actually gives you a number so you know how strong the acid or base is. Consider, for example, borax. You probably don't even know that borax is a household cleaner, and you don't know what its pH is, that's for sure. So let's test it by using a pH strip. You dip the strip in, and then you can check right away. This one seems to have a pH of 9, a mild base. Consider now hydrochloric acid, stomach acid, which you can buy at the hardware store labeled muriatic acid. If we test it with the pH strip, it turns red, deep red. That must mean it has a pH of either 1 or 0, a very strong acid. In fact, it's one of the strongest acids you can find. Now what about soda pop? If you check a soda pop, you wouldn't expect it to be a very strong acid, hopefully not. And it seems to have an acidity or a pH of about 4. That's a weak acid. You'll notice that I've put a lot of my chemicals in these little dishes. You can also use laminated paper or just do it on the tabletop. Around the house, it's easy to find a lot of strong chemicals or even weak ones that can be acids or bases. Have fun, but be sure to wear safety goggles when you're working with strong chemicals. Thank you for joining me, and I'll see you next time.